For our alternate in-class activities for 13C and 13D, we're going to be investigating how changing just one aspect of our formula will affect the braking distance. The first thing we'll do, as you can see in this table, is we are going to look at the braking distances computed for different speeds from 5 miles an hour all the way up to 80 miles an hour. We will hold the friction and the roadway grade and the gravity constant, and we'll compute these values. Now you can do this by hand, but with the 16 or 17 calculations here, that's going to take a while. Once we do this table, we're also going to investigate what happens if we have a different grade. So we'll hold the speed, the gravity, and the friction constant, and we'll look at different grades from 0% up to 35%. So we're going to be filling in these tables. And like I demonstrated in class, what we'll do is we'll use Desmos to help us with this. So what I'm going to do in the video is just run through what we did in class. I've started to create the entries just to save time, but essentially remember there are, 5 different kinds of entries we can make: expressions, notes, tables, folders, and images. We will use some expressions, notes, and a table in this particular activity. I've entered the notes ahead of time. Those are just human readable notes that you can attach to your calculations so that they might help someone reading it make sense. They don't affect the calculations. What we said was that we were going to take miles per hour and shove them into the formula and compute the braking distance. Remember, to do that, our formula requires that our speeds be written in feet per second. So I'm going to create a function first that'll take any speed and turn it into feet per second. So the name of the function is f. F receives a speed, so that's function notation, f of s. We're going to take the speed and we're just going to do dimensional analysis. So we're going to take the speed, which is in miles per hour. We'll multiply by the number of feet in a mile, so that's 5,280 in 1 mile, and then we'll multiply by 1 over the number of seconds in an hour. And when we do that, I'm going to turn this off so it doesn't show up on the graph. When we do that, the value computed by this function will be the speed in feet per second. For example, we know that 45 miles an hour is 66 feet per second. And notice when I type 45 into my function, the answer is 66. So the function is working. Okay, so we have that function. And then the other function that we're going to make is our actual formula. The thing is, we're only going to be changing the velocity. We're not changing any other values. So I'm going to call that distance function d of v, because v is the only variable in our function, the velocity. And remember, the formula is v squared over, and then it's 2 times our gravity number. And since we're holding it constant, I'm just going to type it in as a number. And then our friction number is constant at 0.8. And our grade value is constant at 0.05. So I've now created a function, and I don't need to have that on the screen either. I've now created a function that will compute the distance. Let's put a note in just to label this thing. It's good practice to do that. I'll put it above here, and I'll say the function d of v. So let's see if we can type this thing. Just got to spell function right. We'll say it computes the braking distance with feet per second as the input, right? We need feet per second. And then we'll just put a note in here. Note that gravity, when we have gravity, friction, and grade are all constant. Okay. And so we just entered them in because they're not changing. All right, now here's where things get interesting. Desmos will allow you to make a table. And all you do is go up to the plus sign and you say insert a table. And essentially what we're going to do is construct the table that we need to make for our assignment. So we're going to basically input 5 all the way to 80, counting by 5s, and we'll have the computer calculate the values for us. Now we do want to name these a little differently. Remember, our miles per hour is stored in the variable s. So I'm going to call this independent variable S1, S sub 1. When you type a 1 next to it, it makes it subscript. And then the next calculation we want to have is the feet per second. So that is F of S1. We don't need that to show up on the graph. So we convert the miles per hour to feet per second. So 5 miles an hour is 7.3 repeating feet per second. Then we want to take that value and plug it into our distance function. So we do d of f of s1. And we find the distance to be 0.9793804 feet. Now, we don't want to enter all that into our table. In fact, the table calls for 2 types of entries. One rounded to the nearest hundredth and one to the nearest foot. So the nearest hundredth is just going to be 0.98, right? And then I can actually add one more entry to my table to get the computer to do the rounding for us. There's a function built into Desmos called round, and anything you want to round, you just put in the parentheses. So I'm going to type round, parentheses, and then retype d of f of s1, and it rounds it to the nearest foot. So that 0.979 becomes 1 foot. All right. Now, when you do the activity, then all you're going to do is continue to add values to the row column, and the rest of it will fill in automatically. So my next entry is supposed to be 10 miles an hour. I'm going to type 10, and notice the answers fill in automatically. That's about a stopping distance of 4 feet. So you continue that process after you've created your table, and you'll get all the answers you need for filling in this. So you'll write your answers in and then answer the questions on the right. That's all there is to do it. And the only reason we needed to set up this f of s function is because we need to convert our miles per hour into feet per second before we plug it into our function. So it's really that straightforward. That's all the video is here for, is just to show you how to get started. I've also got an instruction document that I'll post that you can read if you want to have more details, and I'll have a picture of all this so that you can start to copy the top part. Once you copy f of s, d of v, and then the column headers, which is s1, f of s1, d of f of s1, and round d of f of s1, once you copy that stuff in, then anytime you make an entry in the s1 column, the answers will fill in for all the other columns. All right, let's call this video done, and hopefully we'll knock this out in class. In the meantime, take care.